Alright, what's up guys? In this video we're going to pick up some calculus here. We're going to do another integration practice video, show you guys how to evaluate this definite integral from 5 to 6. We got t times t minus 5 all raised to the 10th power integrated with respect to t. Okay, so we need to decide what integration technique to use here. So clearly a u substitution will not work. If we let u equal the inside, for example, t minus 5, well, the derivative of that would just be 1 times dt. How does that help us? It doesn't. And obviously this isn't a trig substitution. This certainly isn't partial fractions. It's not an improper integral. It's not a trig integral. So by the process of elimination, we are just left with integration by parts, which is exactly what we're going to apply now. So recall that integration by parts, we basically get it from the product rule. If you integrate both sides of the product rule, you get the integration by parts formula. And remember, the integration by parts formula is the integral of u dv is equal to uv minus the integral of v du. And we need to determine what is an appropriate u, and dv will be everything we didn't pick. Okay. So neither of these is more difficult to integrate or differentiate than the other. But in this particular case, I'm going to let u equal t, and that means that dv is everything else. So dv will be t minus 5 all raised to the 10th power multiplied by dt. So let's get everything we need. So we need du, that's dt, and then we need v. Remember, v is the antiderivative of dv, so that's the antiderivative of t minus 5 all raised to the 10th power integrated with respect to t. And all we have to do here is just use the power rule, and it's just going to be t minus 5 all raised to the 11th power all over 11. Now we go ahead and go to our integration by parts, and we need to plug the appropriate information in. So I'm going to write this as 1 over 11 t multiplied by t minus 5 all raised to the 11th power. I'm going to pull out a 1 over 11, and what that's going to leave us with is the integral on the inside here of t minus 5 raised to the 11th power dt, and then we'll need to evaluate that from 5 to 6. Okay, so we know if we have our inner integral here, we got t minus 5 all raised to the 11th power dt. We already know what we're going to get for that. That's going to be t minus 5 all raised to the 12th power all over 12. You just use the power rule for that. Don't forget about this negative 1 over 11 that was out there. So we got negative 1 over 11 multiplied by t minus 5 raised to the 12th power all over 12. Okay. So recall that this is just going to, recall that 11 times 12 is 132. There's a negative there. And I'm just going to write it as negative 1 over 132 t minus 5 raised to the 12th power. Okay. Now we go back. So we got 1 over 11 t multiplied by t minus 5 all raised to the 11th power minus 1 over 132 t minus 5 all raised to the 12th power, and that needs to be evaluated from 5 to 6. So hopefully you with me so far on that. So the fundamental theorem of calculus tells us that the upper limit needs to get subbed in first. Whatever we get from that, we subtract whatever we get when we plug into 5. Okay. So it looks like we'll have 1 over 11, and you're just subbing in a 6 for every place you see a t. So this would be 6 times 6 minus 5 raised to the 11th power minus 1 over 132, 6 minus 5, all raised to the 12th power. And we simplify and we see what we get. So it looks like we're just going to end up getting, looks like we're going to get 6 over 11. And that's going to be subtract 1 over 132. Okay. Get my calculator here. I don't know what that is off the top of my head. We would have to get common denominators. We'd have to find the LCM. But let's just do it the shortcut way, plug it in a calculator. Go to math here, and it says that I'll get 71 over 132. Okay. All right, so now we need to plug in the 5. So it should be pretty obvious that substituting in the 5 will just give us 0, because if we substitute in the 5 for t, we'll essentially have 1 over 11 multiplied by 5, but we'll have 5 minus 5 raised to the 11th power, which is 0. So everything over here, regardless of what it is, will be 0. Same scenario over here, be 5 minus 5 raised to the 12th power, that's 0. Multiply that by negative 1 over 32, that also will give us a 0. So when you sub in the 5, you're just going to get 0. So your final answer for this integral here is just going to be 71 over 132. So from 5 to 6, t times t minus 5, all raised to the 10th power, integrate respect to t. Final answer here is going to be 71 over 132. Okay, and that's going to be it. Alright guys, y'all let me know if you got any questions about this. Hopefully it was pretty straightforward, but you know, feel free to ask me questions at any time. So, hope you guys are doing well. I'll see you next time.